Today I want to talk about difference between StateFlow and LiveData, and what pitfalls we can see during migration from StateFlow to LiveData. Shortly about myself. So, as you know, my name is Andrew. I am Android developer at Luno. Also, I'm from Ukraine. I'm a big fan of Kotlin, and Coroutines is my passion. So my colleague Maya and me were speakers at DrawingCon 2020 with topic about migration and refactoring of big application. With release 1.4.0 of Kotlin Coroutines library, we have stable StateFlow and SharedFlow. I'm one of the person who responsible for improving and migration of our application. So we always analyze all new features and libraries to be sure that our team use the most comfortable technologies. So that's why we've done a lot of migrations. So I investigate StateFlow and SharedFlow to understand, could they be useful for us? So StateFlow is very similar to LiveData, but why do we need alternative? Is LiveData is so bad? Actually, it's not so bad. LiveData was designed to create connection between different layers in our application. Most of us use it to create interaction between view model and activity or fragment. And be honest, it's worked fine. But LiveData has some disadvantages. Let's go through them. I think the most annoying thing about LiveData is that value always a nullable type. I hope all of you use Kotlin. So the problem is that LiveData written in Java. So as you know, all objects in Java are nullable. So even if you show for 100% that your value is not null, in Kotlin you should anyway check it for null. In this example, I pass some default value to mutable LiveData, but still I should use question mark, and be honest, it makes me sad. The next one is that you should always pass correct lifecycle owner when observe LiveData in fragment, because lifecycle of fragment and fragments view are different. So if we use this instead of view lifecycle owner, in some cases your application could crash. But during my preparation, I noted that in new Android Studio, there is an error, and you cannot use wrong lifecycle owner. The next point, just imagine that you have some, for example, repository, with LiveData, and it is necessary to observe it in ViewModel. So you must write a lot of boilerplate code. First, you should create observer. Then you should observe forever to some LiveData, for example, in init block. And it's very, very important not forget to remove observer, because it could create a memory leak. And the last thing from my top, if that's LiveData is part of Android X. So it can be used in cross-platform development. But maybe this is not the most terrible thing. Okay, you may ask, hey Andrew, what about coroutines and flow? Could we use it instead of LiveData? The short answer is no. Coroutine is non-sequential, so you could call it and get a result only once. It's designed to be like a regular function, so you just call this function and get a result of work. Okay, what about flow? Flow cannot be used because it is code. What does it mean? So imagine that there is a flow that does some calculation and emit a result of work to this flow. Every time when you collect this flow, it will calculate this value and emit it. So take a look at an example. Here we have a flow that in for loop emit value from 1 to 10, just for example. So when we collect it twice, it will run this for loop twice and emit same value, because flow cannot store and share result of work. So so we cannot use it as alternative of LiveData. Also, be very careful when you use flow, because if in flow you do some intensive work like network call or some database operation, it will do for each collect. So take in mind. We need flow but hot. In coroutines, we have one more beast called BroadcastChannel. BroadcastChannel is a non-blocking channel that create communication between sender and multiply receivers that subscribe for these elements. So some of the realization of BroadcastChannel could also store value. So it could be like LiveData's alternative. But I tried to use it sometime before, and be honest, I don't like it. The most scary thing is that if channel is closed and you try emit a new value to it, it will throw an exception. Another point is that BroadcastChannel was experimental, so it could change a lot after release. But in this case, it was deprecated because we have SharedFlow now. So yeah, that's why I always think twice before use something experimental in our production code. So finally, we find out that state and SharedFlow is the best alternative of LiveData. Of course, there is Eric Java, but comparing Eric Java and StateFlow and SharedFlow is out of scope for current speech. We understand the problem with LiveData, and we know how to solve it. But is JetBrains solution is better? Let's find out. The only thing that you need is replace LiveData with mutable StateFlow and observe with collect. And that's it. Thank you for your attention, folks. No, I'm joking. It is not so easy. First of all, I want to talk about what is SharedFlow and StateFlow and how to use it. Let's start from SharedFlow. SharedFlow is a hot flow that emits values to all consumers that collect from it, and it stores a list of elements. This list called replay cache. So if you need few last values or elements, you should use SharedFlow. It divided to SharedFlow and mutable SharedFlow. So it is same as LiveData, where we used mutable LiveData inside some view model, for example, and public LiveData. So we should do same with SharedFlow. There are two functions to emit value to this SharedFlow. First is suspend function called emit. And second is called try emit that can return true if operation is successful and false if not. Also, there is a subscription count. It contains number of active collectors. So also we could collect on it. The constructor of mutable SharedFlow contain 3 parameters. First, code replay. It is number of elements that will store inside this SharedFlow and replayed to subscriber. Second is extra buffer capacity. This is number of values buffered in addition to replay. And the last is on buffer overflow. This is an action on buffer overflow. Buffer overflow is an enum class that contains 3 strategies. I think this is obvious from this name what they do. So let's move to StateFlow. StateFlow is very similar to LiveData. It contains only one value, and it also inherits from SharedFlow interface. As always, we have StateFlow and mutable StateFlow. So in StateFlow, we have immutable value, and obviously immutable StateFlow value is mutable. In mutable StateFlow, we also have a function called compare and set. But in most cases, it used only in source code of StateFlow and help to solve some issues with multi-threading. Okay, so finally, with StateFlow, we support nullability, and we can use all power of Kotlin. But we should pass init value to constructor of mutable SharedFlow. Another interesting difference between StateFlow and LiveData is that we compare old state and new state. This code I took from source code of StateFlow. So as you can see, we compare a new state and old state, and if they are same, we just ignore new state. So keep in mind that this is really an important difference. But during my preparation, I analyzed some source code of StateFlow, and I found really a few really funny things. First, do you remember that StateFlow implement SharedFlow interface? Take a look how replay cache looks like. This is really simple list that contain only one value. But the most interesting is that how try emit and emit looks like. Look, they do same thing. Try emit always return true and just set value that we pass to it, and suspend function emit cannot be suspended. So instead of these two functions, you could just set value manually and they will do same thing. Actually, StateFlow looks like a SharedFlow, but only with one element. But this is not true. Under the hood, they, in source code, they completely different and designed for different needs. I create a really simple example. In this code, we have StateFlow and SharedFlow, which in and we have some list from 0 to 10, and we emit these values. So if we use StateFlow, collector will display only default value -1 and the last actual state 10. But SharedFlow will display all numbers from 0 to 10. This is because StateFlow and SharedFlow are completely different. So if you're interested only in the most actual state, you should use StateFlow. But if you need all data, all flow of data, you should use SharedFlow. Phew, finally, we finish this overview. Let's migrate our application. So for this case, I create a really simple app. That's where you can enter your name, and clicking update button, you will update this header. And clicking show snack bar, it will show snack bar with your name. Okay, so MainFragment looks really simple. We just subscribe to LiveData and do some our UI things. Okay, this is our MainViewModel, and to update this mutable live data, I use DataBinding because in our application we also use it. So for me, it's very important that StateFlow support it. But the problem is that data binding with StateFlow supported only on Android Studio Arctic Fox. But when I try to build our application, I saw an exception because I missed that I should also update Android Gradle plugin to version 7 Alpha 4 or higher. After that, everything worked fine. Okay, let's go back to our main view model. So in our view model, we have two live datas that provide action to fragment. So we can click two buttons and post username to these live datas. I do interaction between view and view model using DataBinding too. So the only thing that you need to do in MainFragment is just replace observe to collect. But collect is suspend function. So you should launch coroutine first. We will launch it on lifecycle scope, and only then collect our flow. Okay. MainFragment is in main view model. We will use StateFlow because it's good choice for our case. So we should change mutable live data to mutable StateFlow, live data to StateFlow, and post value just with value. Okay, let's test our application. So let's enter some name, yeah, click update button, and as you can see, we update our header. Let's click show snack bar, and wait, what? Nothing happened. But why? Wait. The problem is in function collect. As you know, collect is suspend function, but when we call this collect function, it will suspend until coroutine will be cancelled. So in this case, second flow will never happen. So actually, this is not a big problem. We should just launch coroutine for each flow, and that's it. Or we could use a special action called launch in. So it will create new coroutine and collect just for you. And result code looks like this. And it's more like a rig Java style. But why do we use lifecycle scope? Do you remember that I mentioned previously that lifecycle of fragment and fragments view are different? So this is wrong to use lifecycle scope, right? For this case, in lifecycle, we have three different coroutine builders called launch when created, launch when started, and launch when resumed. In our case, launch when started will fine. So how does it work? So when we use launch when started, our coroutine will be active between state on started and on stop. In other states, it will be paused. But you may ask, how? Because as we know in coroutines, a coroutine could be only active or cancelled. How it could be paused? The answer is pausing dispatcher. This is new dispatcher that created for this case. And under the hood, it uses real magic. So as you know, all magic tricks have some side effects. And in this case, pausing dispatcher pause only collector, but not emitter. So it could waste your resources because emitter will still emit values. So we should use something else. But it's not a problem. We could store our jobs, right? And just cancel them manually. But be honest, this is so many boilerplate code. So could we improve it? Of course, we could launch only one coroutine, and inside this parent coroutine, launch so many coroutines that we need. So we should store only one job, and when we cancel it, it also cancel all child coroutines. Looks like a good plan. Let's create some extension, move code to base classes, but for what? Luckily, we have library called Lifecycle Runtime KTX 2.4.0 Alpha First, where we have extension called Repeat on Lifecycle. So this is, as you can see, suspend function that will create a coroutine between state and its opposite. So if we will pass state, just for example, started, coroutine will be created between state after started and will cancelled after stop. After on destroy methods, our collect will be resumed. So we should use it, and as you can see, this is example how it looks like. Okay, let's migrate our code to it. Let's compare it with LiveData's code. Be honest, new code looks very massive and very ugly. Let's try to improve it. In our KTX library, we have another extension that's called Add Repeating Job. It looks very massive, but it do really simple thing. It just launch coroutine and then call repeat on lifecycle extension with our state. So the code looks like this. But still, I don't want to write so many code just to do simple thing. Let's try improve it using power of Kotlin. For this case, I create inline extension that will call this add repeating job, and on state started, we'll collect our flow. So in most cases, you should just collect flow in fragment, and that's it. I don't want to write a lot of boilerplate code because more code you write, more chances that you do some mistakes. Also, I like extension or some base functions because if in future this API will change, I need to fix only one place instead of whole application. This approach helped me a few times. So finally, our code looks like this. So let's compare it with let's compare it with code from LiveData, and it's look very similar, right? So as you can see, yeah, we just reinvent a well-known API, but one of the benefits is that we could pass this instead of view lifecycle owner. So this is because we launch our coroutine on event on started. So for fragments view and fragment, these two events are same, so it's fine. Oh, there is another way how to do it. You could use extension called flow with lifecycle. So the result code looks like this. So you just call this extension, then call on each to process all our elements, and not forget to call launch in to collect coroutine with our scope. But when I saw this code, I had flashback to times when I used Eric Java, and Eric Java is not bad. But be honest, I don't want to write a lot of boilerplate code just to collect some flow from view model. So be honest, I'm too lazy for it. Okay, let's test our code. I enter some name and then click show snack bar. And when I did my victory dance, I accidentally rotate screen and wait, what? The snack bar appears again? But why? This is not the end of migration. I promise, this is the last issue. So the problem is well known. For LiveData, we use a SingleLive Event that show only once. So for toast or snack bar, it works fine. But how to solve it with flow? Do you remember I talked about mutable shared flow? And in parameter, we have replay. So replay is a number of elements that will store in shared flow. If we set replay as 0 or just set it by default value, we will collect our events only if coroutine is active. So for toast and some other UI events, it will work fine. But of course, this is not perfect solution. And finally, let's test our latest code. So we just replace mutable StateFlow with mutable SharedFlow and remove init value. So let's enter some name, then click show snack bar, rotate our screen, and everything worked fine. Let's do another victory. Oh, sorry. Let's do another victory dance. Okay, so let's sum up. As you can see, there are some pitfalls during migration. It's not just replace LiveData with StateFlow. SharedFlow and StateFlow is not a silver bullet that solve all issues of LiveData. Yeah, they solve some of them, but also create new issues. So before making a decision about migrate your application or not, think about pros and cons. And if this migration will be valuable for you, just go ahead. But if not, just maybe think about some other more important stuff. In our case, maybe I will not recommend for our team to migrate to the StateFlow and SharedFlow because most of the libraries are still in alpha and better to wait to release. Also, for our application, maybe it will be not so valuable. So I think we migrate in future, but not now. Okay, thank you for your attention. Do you have any questions?